I am now going to go over how to find the equation of a sine or a cosine graph of my paddle wheel section. The first thing I want to look at is the 50 diameter is the paddle wheel's complete diameter. So half of a diameter is radius. So starting at the center going up to my point P is 25 feet. The clockwise rotation at 15 RPMs, the bottom of the wheel is 5 feet below the surface of the water. So I drew in 5 feet below the water. Here's my water line, which gives me 20 feet up. Now, if we're looking at an equation, the A is the amplitude, and the amplitude is how far from that axle up and down it's going to be. So in this case, that amplitude is going to be a 25. I'm going to leave the blank the sine or the cosine, and then we're going to move on. Complete the chart. We've got two ways we're going to do it. I'm going to show you completing the chart, but I want to go through this information and the idea of what these pieces in the equation give me. The B value tells me the period, the C tells me a phase shift, the D is a vertical shift. Well, from the water's surface up to the axle has been shifted up 20. That's a vertical shift up. So I'm going to put it under my D value. Now, it doesn't say anything about period. It says a revolution. Remember, if you're in my class, that 15 revolutions per minute. That means that P value is going around the circle 15 times in 1 minute. Well, I don't need 15 times. I need 1 time. I'm going to then divide my minutes into my minutes, but 1 minute is 60 seconds. So the minutes goes away. 15 divides into 64 times. That gives me 1 revolution in 4 seconds. 1 revolution means it goes around the entire circle 1 time in 4 seconds, which tells me that the wheel making 1 revolution in 4 seconds tells me my period, typical sine and cosine, is 2 pi over b in 4 seconds. And to write the equation, I need the value of b. I'm going to multiply by b to get the b value on top of the line in the numerator instead of the denominator, and then I'm going to divide by the 4. Pi over 2 equals the b value that I need for my equation. So I'm going to fill in pi over 2 x, and then I need to determine if this is going to be a sine or a cosine. Well, my p value starts on top of the wheel instead of at the axle. I'm going to use cosine then. And then I'm going to fill in my chart. Now, it looks like I'm finished, but I need to make sure there is no kind of a phase shift that's going on here. And to do that, I'm going to look at my table. So to look at my table, I have 0 to 8 seconds, and I'm going to look starting at P. I need to know how high am I from the water. Well, 25 plus 20 is 45. At time 0, my point P starts at 45. At 1 second, I'm there lined up with that axle, which was 20 feet. At 2 seconds, I'm 5 feet below the water. At 3 seconds, I'm at 20. At 4, I'm back on top of my circle at 45 feet. At 5, I'm back to 20. At 6, I'm 5 feet below. At 7 seconds, I'm back to 20. And then at 8, I'm at 45. If you're looking at the chart, you can see that every 4 seconds, I have repeated. So the period is 4 seconds. Now, taking the TI-84 calculator, if I edit my list 1 and my list 2, I'm going to put the values for my time in list 1. 0, 1, 2, 3, 4, 5, 6, 7, and 8. And then I need to put these values of height in Y2. 45, 20, negative 5, 20, 45, 20, negative 5, 20, and 45. Now I don't need this list 3, but I'll clear that out. And then I'm going to check my mode and make sure my calculator's mode is in radian. I am going to push the stat button and calc by arrowing over, and I need to go down until I find the sine regression right here. And I've read ahead and asked us to verify my answers for the sine regression. So right here where it says store the regression equation, I'm going to push the green alpha and the trace button, and I'm going to pick up Y1 and do some calculations. The 25 was my amplitude, and the D was how much that it moved up. So those two things stayed the same. And I have this pi over 2, and just to double check, I'm going to do pi divided by 2, and sure enough, that's that crazy 1.5079632 decimal. Now my calculator, and I went ahead and wrote this down, my calculator gave me the 25 sine of pi over 2 with a phase shift of pi over 2. But we did cosine with no phase shift. So I'm going to take my calculator and I'm going to type in the cosine equation that we found without a phase shift, and I'm going to change my window by pushing window, and the graph on part E is going from -1 to 8, so I'm going to go to 10, and it is counting by 5s, 1s on my x's, and it's counting from -5 on the y to 50 and counts by 5 on the y-axis. When I graph that, then I'm going to look to see are the two graphs the same. Now, while my calculator is graphing that, and I see it's still working over here, I'm going to take these points and I'm going to move them into their place on my paper. At time 0, I'm at 45. At time 1, I'm at 20. And I go ahead and graph those in. Notice I went ahead and did my horizontal line where y equals 20, just to show that's the axle. That's where that point is rotating around. Now my calculator has finished working. There's no lines there, but it appears that there's only one graph shown. If I want to verify that it is really the same one, and I'm not just going to take it for granted, if I go to my table, if the y1 and y2 values are the same, then the graphs are the same. And I don't care if you give me the answer in terms of sine or if you give me the answer in terms of cosine. Good luck with your test.